February 4th, 1942, Imperial Japanese Navy Headquarters, Tokyo. Commander Minoru Genda studies intelligence photographs spread across the conference table. Aerial reconnaissance images of American industrial facilities, Ford Motor Company, General Motors, Chrysler, all automobile factories, all operating at full capacity, building cars, civilian vehicles. And Genda, architect of the Pearl Harbor attack, Japan's most brilliant naval aviation tactician, feels relieved, because these photographs confirm what Japanese strategic planning assumed. That American industrial capacity, while vast, is dedicated to consumer production, to automobiles and refrigerators and washing machines, products that cannot be quickly converted to military use, that require completely different manufacturing processes, different machinery, different skilled labor. The photographs show no aircraft production, no tanks, no weapons, just cars, endless cars, and Genda calculates America has perhaps 2 years of existing military inventory. After that, they must build new weapons. But converting automobile factories to aircraft production will take years, retooling, retraining, redesigning. By the time American industry converts to war production, Japan will control the Pacific completely. We'll have consolidated conquests into impregnable defensive perimeter. We'll have resources and time to match American production. The mathematics favor Japan. The intelligence confirms it. And Genda files his report with confidence. 16 months later, June 1943, Genda receives a new intelligence. Photographs of the same factories, Ford Willow Run, General Motors Eastern Aircraft Division, Chrysler Tank Arsenal, and Genda stares, cannot process what he sees. These factories, which built automobiles 18 months ago, are now producing aircraft, not converting, not beginning conversion, already producing, at rates that seem impossible. Willow Run, which did not exist in 1942, is now the largest aircraft factory in the world, building one B-24 Liberator heavy bomber every 63 minutes. General Motors, which built Buicks and Chevrolets, is now building Grumman TBF Avenger torpedo bombers and FM-2 Wildcat fighters. Chrysler is building tanks at rates exceeding all German tank production combined, and the conversion happened in 12 months, not years, months. Genda reviews production figures. December 1941, America built 300 military aircraft monthly. June 1943, America is building over 8,000 aircraft monthly, 26 times increase, in 18 months. This is impossible. Industrial conversion cannot happen this quickly. The machinery is different, the skills are different, the supply chains are different, yet the evidence is undeniable. American automobile factories have become the largest military production complex in human history. And Japan, which assumed conversion would take years, now faces enemy-producing weapons at rates that make Japanese victory mathematically impossible. Genda writes urgent report to Admiral Isoroku Yamamoto. We have miscalculated catastrophically. American industrial conversion has occurred at speeds our planning assumed were impossible. They are producing aircraft, tanks and ships faster than we can destroy them. We cannot win war of attrition against this production capacity. Yamamoto reads the report and responds with single sentence. I told them we would run wild for 6 months to a year. After that, I have no expectation of success. The report reaches Yamamoto 3 weeks before his death, shot down by American fighters over Bougainville. Fighters that would not exist without Ford and General Motors building them. And Genda understands. Japan attacked America assuming industrial capacity meant nothing without time to mobilize. They were wrong. American industry mobilized faster than Japanese planners thought physically possible, and that miscalculation doomed Japan from the moment war began. This is the story of how American automobile manufacturers transformed into weapons producers at speeds that shocked Japanese military planners and redefined industrial warfare. How Henry Ford's assembly line techniques, developed for Model Ts, built bombers that destroyed Japanese cities, and how the nation that invented mass production of automobiles applied those same principles to mass production of weapons, creating such overwhelming material superiority that Japanese courage, skill, and sacrifice became irrelevant against mathematics of industrial output. The shock began with intelligence photographs and ended with surrender documents signed aboard battleship built in shipyard that made cars 12 months earlier. Commander Minoru Genda was real, born 1904 in Hiroshima, Naval Academy class of 1924. By 1941, he was one of Japan's foremost aviation tacticians. He planned the Pearl Harbor attack's aviation components, personally led fighter sweeps over Hawaii, and throughout the war, analyzed American industrial capacity for naval general staff. His reports, captured after Japanese surrender and translated by Allied translator and interpreter section, document Japanese understanding of American production capabilities and their shocked realization that initial assumptions were catastrophically wrong. In a 1953 interview preserved in National Diet Library archives, Genda stated, "We knew America had large automobile industry. We did not understand that automobile production experience would allow rapid conversion to aircraft production. We assumed different products required completely different manufacturing processes. We were wrong. American mass production techniques were adaptable. What worked for cars worked for bombers. This flexibility was something Japanese industry lacked. Our factories were specialized, built for specific products, could not easily convert. American factories were designed for flexibility, for rapid model changes. This design philosophy, created for civilian market, became decisive military advantage. The American automobile industry in 1941 was the largest manufacturing sector in the United States. Ford, General Motors, and Chrysler dominated. Combined production exceeded 4 million vehicles annually. Factories employed over 500,000 workers directly. Supply chains involved thousands of component manufacturers. The industry had perfected mass production techniques over 30 years. Assembly lines, interchangeable parts, precise tolerances, just-in-time delivery, continuous improvement. These techniques, developed by Henry Ford and refined by competitors, made America the world's leading manufacturer of consumer goods. But consumer goods, manufacturing and military production were considered fundamentally different. Military equipment required precision engineering, hand-fitted components, skilled craftsmen, low production volumes, high unit costs. Nobody believed that mass production techniques applicable to cars could build complex weapons like aircraft. Nobody except the engineers who actually ran automobile factories. William Knudsen understood. Born Copenhagen, 1879. Immigrated to America, 1899. Rose through manufacturing ranks. Became president of General Motors in 1937. When war began in Europe in 1939, Knudsen recognized that America would eventually be involved, and that automobile industry capacity would be critical. In May 1940, President Roosevelt appointed Knudsen to National Defense Advisory Commission, charged with mobilizing American industry. Knudsen's assessment was blunt. According to minutes from June 1940, meeting preserved in National Archives, American automobile industry can produce anything. We build cars because that's profitable. But our factories can build tanks, aircraft, engines, weapons. The machinery is adaptable. The workforce is trainable. The supply chains are flexible. Give me specifications and production targets. We'll deliver. Military officials were skeptical. Aircraft required precision impossible in mass production. Knudsen disagreed. He had built Chevrolets with tolerances measured in thousandths of inches. Aircraft components required similar precision. His factories already had the equipment and expertise. The first test came with Pratt & Whitney R1830 aircraft engines. These powered multiple American aircraft types. But Pratt & Whitney production capacity was limited, could build perhaps 50 engines daily. Knudsen proposed Ford build them. Ford engineers visited Pratt & Whitney, studied the engine, and reported back. We can build this better than Pratt & Whitney builds it, because we'll use Ford production methods. The R1830 had thousands of parts, many hand-fitted. Ford redesigned for mass production, standardized components, created specialized tooling, built assembly lines. By 1942, Ford's River Rouge plant was producing R1830 engines at rates exceeding Pratt & Whitney's wildest projections, and the engines were better, more reliable, more consistent, because mass production enforced quality control, impossible with hand-fitting. Japanese intelligence noted Ford engine production in reports, but assessed it as anomaly. One successful conversion did not prove systematic capability. They were about to learn otherwise. The consolidated B-24 Liberator heavy bomber was America's answer to strategic bombing requirements. 4 engines, long range, heavy bomb load. Consolidated Aircraft in San Diego built them. Slowly. Aircraft production in 1941 was craft industry. Skilled workers hand-assembled components. Each aircraft took thousands of man-hours. Production rates were dozens monthly. Not hundreds, not thousands. The Army Air Forces wanted thousands, needed them immediately, and turned to automobile industry. Ford agreed to build B-24s, not just assemble them, build them completely. From raw materials to finished aircraft, the plan required constructing an entirely new factory at Willow Run, Michigan, 30 miles west of Detroit. The factory would be largest single manufacturing facility ever built. 2 million square feet under one roof, 1 mile long, quarter-mile wide. Construction began April 1942. First aircraft rolled out September 1942. 5 months from groundbreaking to first production. This was unprecedented in construction and manufacturing history. Charles Sorensen, Ford production chief, designed Willow Run using assembly line principles. Aircraft moved on conveyor system through progressive assembly stations. Each station performed specific tasks. Workers specialized. Components arrived just in time. No inventory delays. No waiting, continuous flow. The B-24 had over 1 million parts. Sorensen broke assembly into 5,000 distinct operations, trained workers to perform each operation perfectly, then connected operations into continuous sequence. What had taken thousands of hours at Consolidated took hundreds at Ford. By mid-1943, Willow Run produced 1 complete B-24 every 63 minutes. By 1944, production peaked at over 400 monthly, 18,000 total by war's end. Japanese intelligence photographs showed this, and Japanese analysts could not believe the numbers, assumed they were propaganda, exaggerated, impossible. One factory could not produce aircraft faster than entire Japanese aviation industry combined. But it did, and the B-24s from Willow Run bombed Japanese-held territories from 1943 through 1945, destroyed shipping, bombed airfields, strategic installations, dropped supplies to Allied forces. The aircraft Japanese planners assumed would take years to produce were arriving in Pacific Theatre in thousands, built by factory that did not exist when war started. General Motors' conversion was equally dramatic. GM operated multiple divisions: Buick, Cadillac, Chevrolet, Pontiac, Oldsmobile. Each had factories, tooling and workforces specialized for specific car models. In 1942, GM converted these factories to military production. Buick built aircraft engines, Cadillac built tanks, Chevrolet built trucks, Oldsmobile built artillery shells, Pontiac built torpedoes. But the most significant conversion was Eastern Aircraft Division, formerly automobile assembly plants, converted to build Grumman aircraft, the TBF Avenger torpedo bomber and FM-2 Wildcat fighter. These were complex aircraft. Grumman built them slowly in Long Island factories, limited capacity. But Eastern Aircraft Division, using GM mass production techniques, built them fast, very fast. By 1944, Eastern Aircraft produced more Avengers and Wildcats than Grumman. Better quality, lower cost, faster delivery. The aircraft that sank Japanese carriers at Philippine Sea included Avengers built by Division that assembled Buicks 18 months earlier. Chrysler's tank production demonstrated conversion capability at largest scale. The M4 Sherman tank was America's standard medium tank. Complex vehicle, cast armor hull, radial aircraft engine or diesel, 5-speed transmission, hydraulic turret reverse, gyro stabilizer for main gun, thousands of parts, precise assembly required. Chrysler built massive tank arsenal in Warren, Michigan, adjacent to automobile factories, used automobile production techniques, assembly lines, progressive stations, standardized components. By 1943, Chrysler Tank Arsenal produced over 1,000 Shermans monthly, more than all German tank production combined. Japanese intelligence noted this, struggled to comprehend scale. One American factory producing more tanks than German entire industry seemed impossible. But photographic reconnaissance confirmed it. Thousands of Shermans leaving Chrysler facilities, shipped to Europe and Pacific, and the Sherman, while not superior to German Tigers or Panthers in armor or firepower, won through numbers. For every Tiger, America produced 20 Shermans. Mathematics of attrition favored quantity. And Chrysler, using automobile manufacturing expertise, provided that quantity. The workforce transformation was as impressive as factory conversion. Automobile workers assembled cars, complex products requiring precision and coordination. But cars and aircraft have fundamental differences. Aircraft must fly. Weight is critical. Structural integrity is life or death. Quality control is absolute. One bad rivet can cause catastrophic failure. Automobile factories hired and trained new workers. Many had never worked manufacturing. Women entered workforce in unprecedented numbers. Rosie the Riveter was not propaganda, she was reality. Women operated drill presses, riveting guns, welding torches, built aircraft wings, fuselages, engines. Ford employed over 40,000 women at Willow Run by 1944. These women built B-24s meeting military specifications, passing rigorous inspections, flying combat missions successfully. The training programs were intensive but effective. Ford's program was 6 weeks. Workers learned blueprint reading, precision measurement, quality standards, specific operations, then worked under supervision until proficient. The combination of detailed training and specialized tasks meant novice workers achieved expert-level quality quickly. Japanese industry never matched this workforce flexibility. Japanese factories relied on experienced craftsmen, multi-year apprenticeships, limited ability to scale. When Japan needed increased production, they lacked workforce to staff factories. America trained workers in weeks, and those workers built weapons that met or exceeded traditionally manufactured equivalents. Lieutenant Commander Shigeru Fukudome, Imperial Japanese Navy Aviation Planning Officer, analyzed American production in 1943 reports. According to documents captured at war's end and housed in National Institute for Defense Studies archives, Fukudome wrote, "American aircraft production now exceeds 30,000 annually. This represents impossible industrial achievement. Their automobile factories have become aircraft factories without losing automobile production capability. They are building both simultaneously. We cannot comprehend how this is possible. Our factories build one product type. Conversion requires complete retooling, takes years, reduces production during transition. Americans convert in months, increase production immediately. This suggests manufacturing flexibility we do not possess and did not anticipate. The supply chain coordination required for conversion was enormous. Aircraft need aluminum, lots of it. B-24 required 15 tons of aluminum per aircraft. Steel, copper, rubber, glass. Hundreds of specialized components, instruments, radios, weapons, each from different suppliers. Coordinating delivery so assembly lines never stopped required logistics, sophistication, unprecedented in civilian industry. But automobile manufacturers had spent decades perfecting supply chain management. Just-in-time delivery, coordinated arrivals, buffer stocks, backup suppliers. These techniques, developed to minimize inventory costs in competitive consumer market, became critical military advantages. Ford's Willow Run received components from over 8,000 suppliers nationwide. Rail cars arrived continuously. Trucks departed continuously. The factory never stopped, never waited for parts, never accumulated excess inventory. This efficiency meant maximum production with minimum overhead. Japanese factories lacked this supply chain sophistication. Centralized planning, government allocation, fixed suppliers. When suppliers failed to deliver, production stopped. No backup systems, no flexibility. By 1944, Japanese aircraft production was limited not by factory capacity, but by component shortages. Engines, propellers, instruments. American factories never faced this problem. Competitive market pressures had created redundant, flexible supply chains that wartime planning merely redirected. The quality control systems automobile manufacturers developed proved critical for military production. Ford's statistical quality control, pioneered for Model A production, ensured every part met specifications, random sampling, measurement, rejection criteria, continuous monitoring. These techniques prevented defects from reaching assembly lines. In military production, this prevented catastrophic failures. Aircraft built with defective components killed crews. Ford's B-24s had lower in-service failure rates than aircraft from traditional manufacturers. Not because Ford built better aircraft, because Ford's quality control caught problems before delivery. General Motors implemented similar systems. Chrysler. Every automobile manufacturer brought quality control expertise that military contractors lacked. Traditional military production relied on final inspection, catching problems after assembly. Expensive, inefficient. Automobile methods caught problems during production. Cheaper, more effective. Japanese aircraft factories lacked systematic quality control, relied on craftsman pride, skilled workers building to personal standards. This worked for low production volumes, failed at scale. As Japan pushed production rates higher, quality declined. Engines failed, structures cracked. Aircraft crashed from manufacturing defects. By 1945, Japanese pilots feared their own aircraft as much as American fighters. because factory quality had collapsed under production pressure. Rear Admiral Sokichi Takagi, Naval General Staff Planning Officer, wrote assessment in March 1944. Document was personal diary never intended for official distribution, captured after war and translated. According to National Archives copy, Takagi wrote, "We have lost production war decisively. Americans are building aircraft faster than we can destroy them, building ships faster than submarines can sink them, building tanks faster than infantry can disable them. Decisive battle we planned, where superior Japanese training and spirit would defeat American material advantages, cannot occur, because material advantages are too vast. They replace losses overnight. We cannot replace losses at all. Factories are bombed, resources are cut off, workers are drafted to military. Production declines while American production increases. This mathematics has one outcome: defeat, not in battle, in factories. We lost war in Detroit and Pittsburgh, not Midway or Guadalcanal. The bomber production numbers tell the complete story. In 1941, America built 1,900 heavy bombers total. In 1942, 2,500. In 1943, over 9,000. In 1944, over 16,000. The increase from 1941 to 1944 was 800%, and 1944 production rates were maintained through 1945. 50,000 heavy bombers built during war, B-17s, B-24s, B-29s, each requiring tens of thousands of parts, precision assembly, rigorous testing, all built by industry that produced zero military aircraft in 1941. The conversion speed was historically unprecedented, and the production scale was impossible by any previous standard. Japan built approximately 17,000 military aircraft total during entire war. America built over 300,000, 17-to-1 advantage. This disparity existed because automobile manufacturers, using mass production techniques perfected over 30 years, built aircraft at rates handcraft methods could never achieve. Fighter production showed similar patterns. Grumman built F-6F Hellcat fighters, excellent aircraft, but production limited by Grumman's Long Island factory capacity. General Motors' Eastern Aircraft Division received contract to build Hellcats under license, using GM production methods. By 1944, Eastern Aircraft produced more Hellcats than Grumman, at lower cost, with better quality metrics. The Hellcat achieved a 19-to-1 kill ratio against Japanese fighters in combat. This was partly superior aircraft design, partly better pilot training, but significantly because GM built so many that American carriers had endless replacements. Japanese carriers, by contrast, faced aircraft shortages. Even when carriers survived battle, aircraft losses could not be replaced. Not because Japan couldn't build aircraft, because production rates were inadequate, and production rates were inadequate because Japanese factories used craft production methods automobile industry had abandoned in 1920s. Tank production demonstrated arithmetic most starkly. Germany built approximately 49,000 tanks entire war. America built over 88,000. Japan built approximately 6,000. America built 14 times more tanks than Japan. And American production was concentrated in a handful of massive factories using automobile techniques. Chrysler, Ford, General Motors, Fisher Body Division, each producing thousands monthly at peak. Japanese tank production never exceeded few hundred monthly, and declined as war progressed. Resource shortages, bombing damage, workforce depletion. By 1945, Japanese tank production had effectively ceased, while American factories continued maximum output until war ended, preparing for invasion that never came, because industrial production made invasion unnecessary. Bombing and blockade, enabled by industrial output, forced surrender without ground invasion. The B-29 Superfortress represented peak achievement of automobile industry conversion. The B-29 was most complex aircraft built during war. Pressurized cabin, remote-controlled gun turrets, advanced engines, sophisticated bomb sight, analog fire control computer, over 55,000 unique parts, each requiring precision manufacturing and careful assembly. Boeing designed it, but Boeing could not produce sufficient numbers alone. Glenn Martin Company built B-29s in Omaha. Bell Aircraft built them in Georgia, and production numbers still fell short. Solution was automobile industry. Fisher Body, GM division that built car bodies, converted to B-29 production. Factory in Cleveland. Workers who had stamped fenders and welded car bodies now built bomber sections, wings, fuselages, tail assemblies, shipped to Boeing for final assembly. Fisher Body produced over 500 B-29s, using techniques developed for Chevrolets and Buicks. These aircraft bombed Japan from 1944 through 1945, destroyed Japanese cities, dropped atomic bombs on Hiroshima and Nagasaki. Aircraft built by division that made automobile bodies 2 years earlier ended the war. Captain Atsushi Oi, Imperial Japanese Navy logistics officer, analyzed American production capability in September 1944, report to Naval General Staff. According to captured documents housed in Gordon Prang collection at University of Maryland, Oi calculated, American production now exceeds combined Axis production by 3-to-1 margin in aircraft, 4-to-1 in tanks, 10-to-1 in shipping. This advantage increases monthly as American production accelerates and ours declines. Recommendation: negotiate peace immediately while limited bargaining position remains. Continuing war guarantees total defeat. Americans will bomb Japan until nothing remains. Then invade with overwhelming force. We cannot win, can only delay inevitable. Oi's report was ignored. Japan fought on, and Oi's predictions proved accurate. The conversion speed and production scale shocked not only Japanese planners, but also British and Soviet allies. British industrial planning assumed conversion required years. Soviets, despite massive production capacity, needed American factories to supplement shortfalls. Lend-Lease provided aircraft, tanks, trucks, many built by American automobile manufacturers. Studebaker built trucks. Over 200,000 shipped to Soviet Union. These trucks moved Soviet armies from Moscow to Berlin, supplied offensives that destroyed German forces, built by company that made civilian automobiles. Douglas Aircraft built C-47 transport planes, thousands of them. But fuselage sections came from automobile industry suppliers. Final assembly was Douglas. Component manufacturing was dispersed to automotive supply chain. This distributed production model, created by automobile industry's competitive environment, proved incredibly resilient. Bomb one factory, others continued. No single point of failure. Japanese industry, by contrast, relied on concentrated production sites. Bomb one factory, entire production lines stopped. By 1945, American bombing had crippled Japanese manufacturing by destroying few key facilities. Japanese had no backup capacity, no alternative suppliers, no flexibility. Henry Ford was interviewed by Fortune magazine in 1944. Asked how automobile company built bombers so successfully, Ford replied, "We build whatever needs building. Car, truck, tractor, bomber, same process. Design for production, standardize components, train workers, run assembly line. Whether product has wheels or wings doesn't matter. Manufacturing principles are universal. We proved this building Liberty engines in First World War, Proved it again with B-24. Anyone saying civilian industry can't build military equipment doesn't understand manufacturing. Given specifications and priorities, American industry can build anything, in any quantity, faster than competitors imagine possible. That's not patriotic boast, that's mathematics of mass production. Ford's confidence was earned. Willow Run's production demonstrated that complex military equipment could be mass-produced using techniques developed for consumer goods. This lesson influenced post-war military procurement. Military specifications began incorporating design for production principles. Standardization, modular components, simplified assembly. Learning from automobile industry's successful wartime conversion, the strategic implications of industrial conversion were understood by few Japanese leaders before war. Admiral Yamamoto famously warned that attacking America would awaken sleeping giant. Most dismissed this as defeatism, assumed Japanese fighting spirit would overcome American material advantages. Admiral Yamamoto knew better. He had studied at Harvard, served as naval attaché in Washington, seen American industry firsthand, toured automobile factories, understood production capacity. His warnings were ignored, and his prediction proved accurate. Japan ran wild for 6 months after Pearl Harbor. Then American production engaged, and Japanese advances stopped, not through single decisive battle, through accumulating weight of material superiority. Every replaced American ship, every replacement aircraft, every new tank, came from factories that shouldn't have been able to build military equipment, but did, faster and better than anyone predicted. The human cost of industrial miscalculation was paid by Japanese soldiers and civilians. Superior American equipment meant Japanese forces fought at permanent disadvantage after 1943. Aircraft were outnumbered, ships were outnumbered, tanks were outnumbered, and Japanese training and courage, while exceptional, could not overcome 5-to-1 or 10-to-1 numerical disadvantages. Pilots died because replacement aircraft didn't exist. Sailors died because damaged ships couldn't be repaired without resources. Soldiers died because ammunition and food couldn't reach front lines. All consequences of production imbalance. Japan's industry operated at maximum capacity throughout war, produced everything possible given resources and infrastructure. But maximum capacity was insufficient against enemy whose automobile factories alone outproduced Japan's entire military-industrial complex. The mathematics were unforgiving, and the outcome was predetermined once industrial conversion succeeded. Commander Minoru Genda survived the war, became Lieutenant General in post-war Japan Air Self-Defense Force, served until 1962. In 1976 interview with Japanese newspaper Yomiuri Shimbun, Genda reflected on American industrial conversion. Our greatest strategic error was underestimating American industrial flexibility. We calculated that automobile factories could not quickly convert to aircraft production. We were wrong. American industry was designed for rapid model changes and production flexibility. What worked for annual car model updates worked for converting to military production. This flexibility, created by competitive civilian market, became decisive military advantage. Japanese industry was centrally planned, specialized, inflexible. We could not convert rapidly even when desperate. This difference, more than any battle, determined outcome. We lost war in our strategic assumptions about American industry, not on battlefields where our soldiers fought bravely, in planning rooms where we miscalculated enemy capabilities. The statistical evidence supports Genda's assessment. American aircraft production 1941 through 45 totaled over 300,000 military aircraft. automotive industry produced approximately 40%. Over 120,000 military aircraft built by factories that made cars in 1941. This was largest and fastest industrial conversion in history. Created material superiority that made Japanese defeat inevitable, regardless of tactical victories or strategic brilliance, because wars of attrition are won by production, and America's production, leveraging automobile industry's mass manufacturing expertise, exceeded Axis production combined. The shocked Japanese officers who saw intelligence photographs in 1943 understood. Their nation had attacked enemy whose industrial capacity was not just large, but adaptable, flexible, scalable. And that enemy had converted peaceful production to military output faster than Japanese planning assumed physically possible. The war was over, the battles continued, but outcome was determined. In Detroit and Pittsburgh and Cleveland, where automobile workers built bombers that destroyed Japanese empire, one every 63 minutes, until empire surrendered. And the sleeping giant, awakened by Pearl Harbor, returned to building cars, having proven that manufacturing excellence transcends product type, that assembly lines work for cars or planes, and that nation which perfected mass production of consumer goods could apply same principles to weapons, with devastating effect, against enemy who never imagined conversion could happen so fast, or produce such overwhelming material advantage. The shock was real, the evidence was undeniable, and the outcome was inevitable. From the moment Ford built first B-24, and American automobile industry demonstrated that making cars and making bombers require same fundamental skills, just applied differently, to deadly effect.